Hello, this is Mr. Brooks and welcome to Lesson 8.5, Angles of Elevation and Depression. In this lesson we're going to use angles of elevation and depression to solve problems. And why? To use angles of elevation to calculate the height of a natural wonder. First, let's try to understand what an angle of elevation and an angle of depression are. Okay, we got the person standing on the ground looking up to the hot air balloon. They're looking up at an angle of 38 degrees with a horizontal line. So that would be an angle of elevation. The person in the hot air balloon is looking down to the person on the ground at an angle of 38 degrees with a horizontal line. So that would be an angle of depression. Okay, in example 1, it asks you to identify the given angle as an angle of elevation or depression and describe it as it relates to the situation. Hopefully for angle 1 you would say it is an angle of depression from the mountaintop down to the hiker. Angle 4 is an angle of elevation from the cabin or the hut up to the hiker. Now, please pause the video while you try to figure out angles 2 and 3 as angles of elevation or depression and describe them as it relates to this situation. Hopefully you said angle 2 is an angle of elevation from the hiker to the mountain peak. Now please pause the video while you try to figure out angle 3. Hopefully you've said angle 3 is an angle of depression from the hiker to the hut or cabin. In example 2, we're asked to try to get the height of the Delicate Arch in Arches National Park. As you can see in the drawing at the left, you got the surveyor that sets up his theodolite in transit, and because then you can get a horizontal line with his transit, and you can see you got an angle of elevation of 48 degrees, and he's 36 feet from the base of the arch. Let's see if we can figure out how to get x. Please pause the video while you try to figure this out. Well, we know back from lesson 8.3 that tangent equals opposite over adjacent. So tangent of 48 degrees is going to equal x over 36. So we're going to multiply both sides by 36, and we end up with 36 times the tangent of 48 degrees equaling x. Hopefully you agree your 36's cancel. So we punch this into our calculator, and we're going to get approximately 40 to the nearest tenth. And then, as you can see from the picture at the left, the surveyor set up his theodolite 5 feet from the bottom of the arch. So to get the total height of the arch, we're going to have to add 5, giving us the arch to be approximately 45 feet. Quick check number 2 asks us to find how far it is from you to a climber on a distant cliff. And so they're asking for the line of sight distance. So you need to make sure you understand you're looking for x in this figure. So please pause the video while you try to figure this out. Well, we know from lesson 8.4 that cosine equals adjacent over hypotenuse. So on this one, cosine of 32 degrees is going to equal 1,000 over x. Then we're going to multiply both sides by x, and you're going to get x times the cosine of 32 degrees equals 1,000. Then hopefully you agree you got to divide both sides by the cosine of 32. And so you get x to be approximately equal to 1,179 feet. Okay, example 3 asks us to figure out how far the airplane is from the airport. It says the airplane is at a height of 2,714 feet. The airport is at an altitude of 1,007 feet. If the airplane is starting at a 3-degree angle of descent, how far is the airplane from the airport at the beginning of its descent? So the first thing you're going to have to figure out is how much higher is the airplane than the airport. To do this, you're going to take 2,714 minus 1,007. Hopefully we'll agree that this distance here is 1707. Alright, now we got to set up, using our trig functions, we got to set up an equation. Well, as we remember, sine is opposite over hypotenuse, so we're going to say the sine of 3 degrees equals 17 over 7. Sine of 3 degrees equals 1707 over x. To solve this, we're going to multiply both sides by x, so you get x times the sine of 3 degrees equals 1707. Then we're going to divide both sides by the sine of 3 degrees, and we get x to be approximately equal to 32,616.2. 32,616.2. Now, that tells us how many feet, that's in feet, how far the airplane is from the airport in feet. How are we going to change this to miles, which is what the question asks? Hopefully you remember that there are 5,280 feet in a mile. So we divide that by 5,280, and we're going to get approximately 6.2 miles is when the airplane needs to begin its descent down to the airport. Okay, for our last problem, they're telling us a plane spots a life raft at an angle of depression of 26 degrees. The plane is at an altitude of 3 kilometers above sea level. And of course, the life raft is at sea level. What is the plane's surface distance, d, from the raft? First, I would hope you're going to draw a picture and then try to figure it out. Please pause the video while you try to draw a picture to set up this problem. Okay, hopefully you came up with a picture similar to what I have. Now, how are you going to figure out d? You're looking for the surface distance, the distance along the surface of the water. Again, the plane is 3 kilometers high with an angle of depression to be 26 degrees. Please pause the video while you try to figure out how to get d. Well, again, tangent equals opposite over adjacent, so hopefully you're going to say tangent of 26 degrees equals 3 over d. Then you're going to multiply both sides by d, giving you, our d's cancel, giving you d times the tangent of 26 degrees equals 3. Divide both sides by the tangent of 26 degrees, and you get d to be approximately equal to 6.2 kilometers. This concludes lesson 8.5.